Let's look at the solution of number system bytes. How many 3-digit natural numbers are there such that the unit digit of each of which is always more than the tens as well as the hundreds digit? Okay, let's see. We can have the unit digit is 2. Unit digit is 2, in which case the leading digit has to be 1 and the middle digit can be 1 or 0. So 2 ways, 1 way, you get 2 such numbers. If the unit digit is 3, the leading digit has to be 1 or 2 ways, and the middle digit can be 1, 2 or 0. So 3 ways, so you get 6 numbers. If the unit digit is 4, the leading digit can be 0, 1, 2, 3. Sorry, 1, 2, 3. So 3 ways, and middle digit can be anything from 0 to 3. So 4 ways, we get 12 numbers. Hopefully by now you have seen what sort of series is emerging: 1 into 2, 2 into 3, 3 into 4, and we will keep on going, and we'll keep on going. We'll get 4 into 5 with 5 at the units place. With 6 at the units place, we'll get 5 into 6. With 7 at the units place, we would get 6 into 7. With 8 at the units place, we will get 7 into 8, and with 9 at the units place, we'll get 8 into 9. Let's get all the cases in row. 20 numbers, 30 numbers. Okay. Right now, I'm also seeing each of these numbers are nothing but sum of first and natural number into 2. This is 42 numbers. This is 56 numbers, and this is 72 numbers. We simply need to do summation of these values. Let's see, 72 and 2 gives me 74. 56 and 6 gives me 62. 42 and 12 gives me 54. 30 and 20 gives me 50. Okay, so I remove these. I get a 10 separately. 10 and 70 gets me 80. 80 and 60 gets me 140. 140 and 50 and 50 gets me 240. How many 3-digit natural numbers are there? Such that unit digit of each of which is always more than the tens as well as hundreds digit. Answer should be 240. Next question: how many natural numbers below 500 are divisible by at least one of 2, 3, 4, 5, 2, 3, 4, 6, 8, or 10? The brilliant thing here is, can you see? 2 is a factor of 4, is a factor of 6, is a factor of 8, is a factor of 10. So as soon as you have removed multiples of 2, as soon as you have removed multiples of 2, you have removed multiples of these numbers altogether. This question was only about 2 and 3. The remaining numbers were nothing but distraction. Okay, so if we are looking at multiples of 2 under 500, see, the question is below 500. We are going to get 249 multiples of 2. How many multiples of 3 will we get? 480 by 160 plus 18, so 166 multiples of 3. The problem is multiple of 6 would also be present here, We are counting multiples of 6 twice, so we need to remove their count once. So multiple of 6, how many times will we get them? 480 would be 80 plus 3. Okay, 83. So the answer to the question is going to be 249 plus 166 minus 83. These two, if I cancel, I will get 83 only. So 249 plus 83. So 250 and 82. So 332. There are 332 numbers below 500 that are divisible by 2 or 3 or 4 or 6 or 8 or 10. As soon as you are a multiple of 2, you're all, or you have, as soon as you have included multiples of 2, you have also included multiples of all other possibilities, as in all other possibilities specific to this case. You have multiples of 4 also included, you have multiples of 6 also included, so on and so forth. Okay. Large one. If first 4985 natural numbers are put side by side to get a big number like 1, 2, 3, 4, something, 4984, 4985, last terms, which digit will be exactly in the middle. Okay. Let's see how many digits are used up until this time. The number of digits used up will be for single digit numbers. There are 9 numbers. Everyone uses 1 digit. There are 92 digit numbers. Every number uses 2 digits. There are 903 digit numbers. So we've got 9 here, 180 here, and 2700 here. But from 1000 to 4985, how many numbers are there? 3986 numbers are there. 3986 numbers are there, and each of them are using 4 digits. So 3986 into 4. 4000 into 4 minus 14 into 4. So 4000 into 4, so 15,944. We have to add up these 4 values. Okay. So I get 2889 from here. This is a fairly common occurrence wala number. How many 3 digit, 2 digit digits ka usage? So I directly know it. Adding it now, 4 and 9 gives me 3, 1 carried over. I get 3, 1 carried over. I get 8, 1 carried over. I get 8, I get 1. Hopefully the summation is correct. Okay, seems right. Now, if I have these many digits and I'm looking for the digit exactly in the middle, first thing I would have to do is just identify. If there are 3 digits, the digit exactly in the middle is how? If there are 5 digits, the digit exactly in the middle is identified how? Hopefully, pattern wise, you can see it is 3 by 2 plus 0.5. Here it is 5 by 2 plus 0.5. The spot for the middle digit is identified that way. So if I have to identify the middle digit here, I would have to go this number divided by 2 plus 0.5. This number divided by 2 will give me 9416.5 plus 0.5, or I am seeking the 9417th digit. I am seeking 9417th digit in the consideration. Okay. Out of these 9417 digits, can you see these many numbers these many digits I can straight away remove? So 9417 minus 2889. 17 minus 9 is 8. 10 minus 8 is 2. 13 minus 8 is 5. 8 minus 2 is 6. Okay. Among the numbers that are 4 digit long, I'm looking for the 6528th digit, which would mean, because every number will now use 4 digits, I can divide this by 4. I'll get 1632. I'm looking for 1632th numbers. Last digit. So among the 4 digit numbers, I need to identify which is the 163nd number, 1632nd number. So 1000 is the first number, 1001 is the second number. Hopefully you can see whatever number you try to identify, the difference between these two is always 999. So if I'm looking for 1632nd number, it is going to be 1632 plus 999 or 2631. The last digit of this 1 is the answer to this question. Amazingly well thought out and reasoned question. Of course, something not that you would expect in an exam, but amazingly well thought out and reasoned question. Okay. If D is the absolute difference between a 3-digit number, 3-digit natural number, and the sum of the digits of the number. Okay. So a 3-digit natural number will be referenced this way. And whenever you remove the sum of the digits of a number, whenever you remove sum of the digits of a number, the number will become a multiple of 9. The number will become a multiple of 9. Anyway, so minus A, minus B, minus C. C is entirely gone. I'm left with 99A plus 9B. Okay. So 9 times of 11A plus B. Cool. If D is a multiple of 12 and greater than 504. Okay. See, this was D. This is D. And this is D. If D is supposed to be a multiple of 12, hopefully you can identify D is a multiple of 36 now. You have to be a multiple of 12. You have to be a multiple of 9. So you're a multiple of 36. Or in other words, 11A plus B, 11A plus B has to be a multiple of 4. Has to be a multiple of 4. Okay. Now D has to be a multiple of 6 and 36 and greater than 504. Let me see. 504 is itself divisible by 36. It is itself divisible by 36. Or why do I even care for this? I don't care for this. Let's see. Can I go? 504 divided by 9 gives me 56. Okay. So if 504 was allowed, I would have gotten 9 into 56. D would have been there. 9 into 56. So if I'm looking at subsequent values of D, if I'm looking at the list of subsequent values of D, I know this 11A plus B has to be a multiple of 4. So let me just check. Can I make 60 out of 11A plus B? Even if I can find one case, my life is chill. So for 60, I would need 5 and 5. Yes, it works. For 64, I will get 5 and 9. Yes, it works. For 68, I will get 6 and 2. Yes, this works. For 72, I will get 6 and 6. This also works. For 76, I cannot make 76. I cannot have 76. See, here the value of D would be 540. Here the value of D would be 576. But I'm not really concerned with what precise value D ends up taking. I'm more concerned with how many cases I can make. Okay. So for 80, it would be 7 and 3. For 84, it would be 7 and 7. For 88, it would be 8 and 0. For 92, this list making is becoming problematic because up until when do I have to see the list? Oh, I have to see the list up this far. Look at this. This is an expression that has to be a multiple of it. Can you see the largest possible value that A and B can take? Because they are single digit numbers. The largest value that A and B can take is 9, in which case we can go up to a maximum of 108. So I only have to check up until 108. 92 could I make? 8 and 4. 96 could I make? 8 and 8. 100 could I make? 9 and 1. 104 could I make? 9 and 5. And 108 could I make? 9 and 9. Yes. So all cases are possible. See, this is the limit after which everything starts becoming possible. Each of these cases are possible. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Another well thought out question. There are going to be 12 values that they can assume. Next, how many 5-digit numbers are there such that the digits at the hundreds place, units place, and 10,000s place are the first 3 digits of a geometric progression in any order? Okay. Thousands place and hundreds place and units place. These 3 spots need to have a GP in any order. So GPs I can make with single digits. The simplest one that I can make is 111, 222, 333, so on and so forth up until 999. In this case, there are 9 such cases into the order in which you can rearrange them in these 3 spots is just 1, because all the 3 numbers are identical. And in the remaining 2 spots, you can fill it up in 10 into 10 ways, or you get 900 such numbers. Now the other GPs, not one Wali GPs, you will in single digits. Hopefully by now you have practiced enough that you would be able to identify these series straight away. These 3 are fairly simple to identify. This is the one that people miss out on. 4, 6, and 9. 4, 6, and 9. This is also a GP. The common ratio is not integral, yet the individual digits themselves are involved. So in this case, if I were making cases, there are 4 such cases. Because all the numbers are distinct, they can rearrange themselves in 3 factorial ways. And then the remaining 2 blanks can be filled in 100 ways, as was always the case. So we get 2400 numbers from here. So I've got 900 here, 2400 here. Altogether, how many total numbers? The answer will be 3300 numbers. That will be all for this episode. Hopefully you learned something. Okay, bye.